Hi viewers, welcome to my channel. In the present class, now I am going to discuss the topic equation of motion of a particle moving under the central force. So before that, let me repeat the definition of the central force. The force is said to be central force. It always acts towards or away from the fixed point, and whose magnitude always depends on the distance of the particle from the fixed point. It is represented as F bar equal to F of R into R cap. Example for central force, gravitational attraction force between two bodies, electrostatic attraction or repulsion force existing between two charges, the spring elastic force. These are the example for the central forces. So when the particle is moving subjected to the central force, the equation which describes its motion is nothing but equation of motion of the particle moving under the central force. That we have to derive here. Right. So according to our definition, let us consider a particle is moving under the central force. Then the force acting on the particle always towards a fixed point. Therefore, the direction of acceleration is also towards a fixed point. So here the particle is possessing only the radial acceleration. Its tangential acceleration is 0. So that is the key point here. So with that, let us start our derivation, right? Yes, I am writing. Consider a particle is acted upon by a central force then its radial acceleration ER is equal to d square r by dt square minus d square r by dt square minus r d theta by dt whole square or d theta by dt whole square. That equals to, I am writing minus p, say equation 1, where minus sign indicates that the acceleration and the r cap are in opposite direction, or the force and r cap are in opposite direction. Okay, next tangential acceleration. Tangential acceleration AT is equal to tangential acceleration AT equal to 1 by r d by dt of r square d theta by dt equals to 0. Okay, so from this we can write d by dt of r square d theta by dt equal to 0. R square d theta by dt is equal to constant. Say that is h, small h, constant. Okay. So from this, d theta by dt is equal to h by r square, that equal to h u square, equation 2. Since where r is equal to 1 by u, r u is equal to 1 by r. So taking that, u is equal to 1 by r. Okay. From this, differentiating with respect to time, du by dt is equal to minus 1 by r square dr by dt. That equal to minus 1 by r square du by dt. From this, you write dr by dt as the subject is equal minus r square du by dt. Okay, then dr by dt is equal to r equal to 1 by u. Then this will be minus 1 by u square du by dt. Okay, so దీన్ని రీఅరేంజ్ చేసి రాస్తే ఓకే సో దాన్ని రీఅరేంజ్ చేసి రాస్తే మనకి ఏమొచ్చింది dr by dt is equal to minus 1 by u square du by dt. That equals to minus 1 by u square du by d theta into d theta by dt. ఇలా రాయొచ్చు. Okay, but d theta by dt equal to hu square we have. This is equal to minus 1 by u square du by d theta into d theta by dt. We have hu square. Can u square cancel? Then dr by dt is equal to minus h du by d theta. Okay, h du by d theta. దీన్ని ఈక్వేషన్ 3 అనుకున్నాం. ఓకే, అగైన్ దీన్ని మళ్ళీ విత్ రెస్పెక్ట్ టైం డిఫరెన్షియేట్ చేస్తే లెఫ్ట్ సైడ్ d square r by dt square is equal to minus h constant d by dt of this d by dt of du by d theta. Okay, that is equals to దీన్ని అగైన్ రీఅరేంజ్ చేసి రాస్తే minus h d by d theta into du by d theta into d theta by dt. ఇలా రాయొచ్చు. Okay, that is equals to minus h d by d theta of du by d theta d square u by d theta square, right, into d theta by dt. Okay, but d theta by dt is equal to, we have d theta by dt equal to what we have, minus d theta by dt equal to hu square. So let us substitute that d square u by d theta square into this is hu square. Okay, then that gives minus hu square d square u by d theta square. Then equation 4. Okay, అంటే మనం dr by dt is equal to minus h du by d theta, మళ్ళా దాని విత్ రెస్పెక్ట్ టైం డిఫరెన్షియేట్ చేసాం. d square r by dt square equal to minus h square u square d square u by d theta square వచ్చింది. అంతే. నా దీని నుంచి ఇప్పుడు d square r by dt square ఈ వాల్యూస్ ని ఫస్ట్ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేద్దాం. దట్ ఈస్ రేడియల్ యాక్సిలరేషన్ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే, సో వాట్ ఐఎమ్ రైటింగ్ ఫ్రమ్ ఈక్వేషన్స్ okay, yes, ఇప్పుడు వీటిని ఫ్రమ్ ఈక్వేషన్స్ 1 to 4, from equations 1 to therefore we can get what is that there we have a radial acceleration AR is equal to d square r by dt square minus r d theta by dt whole square that equals to minus p. ఇది ఈక్వేషన్ 1. దీంట్లో మనం d square r by dt square d theta by dt వాల్యూ సబ్స్టిట్యూట్ చేయాలి. చేస్తే minus h square u square d square u by d theta square, because d square r by dt square equal to minus h square d square u by d theta square minus r అంటే 1 by u d theta by dt equal to h u square whole square equal to minus p. So both sides minus తీసేస్తే h square u square d square u by d theta square, ఇక్కడ h square ఒక u క్యాన్సిల్ అయిపోతే ఏం మిగులుతుంది మనకు ప్లస్ h u cube is equal to right side p. Okay, both sides the left side h square u square, ఇక్కడ h square u cube, h square u square కామన్ తీస్తే left side d square u by d theta square plus u is equal to p. Right. So from this d square u by d theta square plus u is equal to p by h square u square, where what is p? This is the force per unit mass in magnet. Acceleration is nothing but force per unit mass in magnitude. So this differential equation is known as the polar equation of motion of the particle when it is acted upon by the central force, or the equation of motion of a particle which is moving under the central force. So this second order differential equation, that is d square u by d theta square plus u equal p by h square u square, that represents the equation of motion of the particle under the central force. Okay. Here you have to remember that what is u? U is equal to the reciprocal of radius vector. What is p? P is nothing but the magnitude of the force per unit mass, right? Magnitude of the force per unit mass. What is h here? H is equal to angular momentum per unit mass, that equal to r square d theta by dt. R square d theta by dt. Right. సో ఈ లెక్చర్లో మనం ఏం డిస్కస్ చేశామంటే ఒక పార్టికల్ సెంట్రల్ ఫోర్స్కు లోబడి మూవింగ్లో ఉన్నప్పుడు దాని ఈక్వేషన్ ఆఫ్ మోషన్ ఏంటి అనేది మనము డిరైవ్ చేశాం. ఓకే, అది d square u by d theta square plus u equal to p by h square u square.